Year 2002, paper 2, maximum mark 10. The diagram shows a square ABCD of side 4 centimeter. So this is all have sides 4 centimeter. The midpoints of PQRS of the sides are joined to form a second square. So you can see here there is a PQRS. So basically this every side now divided into 2. You are forming by connecting them another square. Show that PQ is equal to, that means the side of new square is equal to 2 root 2 centimeter. You know one rule, whether it's a rectangle or a square, always their adjacent sides makes a 90 degree. So this is a 90 degree. You can take any triangle. You know this is 2 because it is a midpoint where P and Q. So this becomes a hypotenuse. So I am using a Pythagoras theorem. PQ square is equal to 2 square plus 2 square, which is 4 plus 4, which is 8. So PQ is equal to square root of 8, which is square root of 4 times 2. Square root of 4 times 2 is square root of 4 times square root of 2, which is 2 root 2 centimeter. So your first part is done. Find the area of PQRS, that means the area of this another square, inside square. Area of a square is basically length square. This side is 2 root 2. So as this is 2 root 2. So square means what? Area is length square is 2 root 2 square, which is 2 square is 4 and root 2 square is 2. 4 times 2 is 8. So this area is 8. Second part. The midpoints W, X, Y, Z of the sides PQRS are now joined to form a third square. So again you are repeating the same process. Now you are taking the midpoints of PQ, QR, RS and PS as W, X, Y, Z. You are connecting them, so you are getting a new square. Write down the area of the third square. They are not asking to find out the length of that, but they are directly asking the area of that. So here is the diagram. We know this is 2, this is 2, so this becomes 2 root 2. When this is 2 root 2, this individually becomes what? Root 2 and root 2. Again, we know the condition that adjacent sides of a square or rectangle always make a 90 degree. So you can pick up any triangle. So you can see here the blue line. WX is basically hypotenuse because angle Q is 90. This is root 2, this is root 2. So PQ is 2 root 2. So PW is root 2. WQ is root 2. In triangle WPZ, they are taking this triangle. You can take any triangle. WZ square is equal to root 2 square plus root 2 square, which is root 2 square is 2. Another root 2 square is 2. 2 plus 2 is basically 4. So WZ square is equal to 4. So WZ is equal to root of 4, which is 2. So now you got the length of inside square is 2. It is easy. Now if I want to find out the area of this square, is basically length square, so 2 square basically 4. So inside square area is 4. Show that the areas ABCD, PQRS and WXYZ form a geometric sequence. Find the common ratio of this sequence. We know the area of first square is 16 because the length are 4. So first area square is 16. Second area square we found out is 8. And third area we just found out is 4. They are saying show that it's a geometric sequence. Show that. They are not assuming that. To show a geometric sequence, you have to show consecutive two ratios should be same. So next ratio is 8, previous ratio is 16, 8 over 16 is 1 by 2. Next ratio is 4, next value of area is 4, previous area is 8, 4 over 8 is 1 by 2. Both are giving the same ratio, so it is a geometric sequence. Now the process of forming smaller and smaller squares by joining the midpoints is continued indefinitely. This is very important. They make it very bold later. Find the area of the 11 square. 11 square, I know the first area. I'm interested in area, not the length, because they are talking about the area. So first area, the main square area is 16. We found out in the previous part ratio in the area is 1 by 2. Now suddenly they are skipping in between and they want to find out the area of the 11 square. So u11, un is equal to u1 times r raised to n minus 1. un is my u11, so n my 11. So here 11 minus 1 is basically 10. u1 is 16 as it is. R is 1 by 2 as it is. 16 I am keeping as it is. 1 raised to 10 over 2 raised to 10. 1 raised to 10 is 16. 2 raised to 10 is 1024. Type this on a calculator. 16 over 1024, you will get 0.015625. If I'll round off to 3 significant figures, these are not significant figure. Your first significant figure is 1, then 5, then 6. After that number is 2, which is less than, so your answer is 0.0 as it is, and 156. That is your final answer. Calculate the sum of all the areas or sum of all the squares. It is clearly written indefinitely, so more you will go, the lesser area you will get. And why I'm using a sum to infinity, because your r is basically 1 by 2, and 1 by 2 is basically coming between minus 1 and 1. So you cannot use a regular sum formula, you have to use sum to infinity formula. That is u1 over 1 minus r. u1 is 16, r is 1 by 2, 16 over 1 minus 1 by 2, so 16 over 1 by 2, which is 32. Thank you.